Hi children, welcome to the Physical Science digital class. Children, humans are blessed with a specialized mechanism, that is vision, by which we can see this colorful world and enjoy the beauty of nature. You know children, human's eye can recognize 10 millions of colors. How it is possible? And you might have observed that so many people wearing the spectacular. Look at me. Even I am also wearing the spectacular. Why the people wear the spectacular? So what is the reason behind this? To find the answers for these all questions, we are going to discuss about our human eye, how it works, how it helps to see the objects, things and colors which are in different size, shape and also different in color. So let us start the lesson with a small activity. Take your textbook and read it. Just simply read it. While you are reading, just slowly move your textbook closer to your eyes. Closer and closer to your eyes, like this. What do you observe? What do you experience? I think you might have experienced that the letters will be blurred and your eye strained. So why it is happening? Means there is a minimum distance should be there between the object and your eye. So what is that minimum distance? That minimum distance is known as least distance. To calculate the least distance of human eye, so observe this picture. Take a rod of length 20 centimeters and just move it from your eye away horizontally, slowly. And fix it at a position at what point you can see the whole object clearly, and measure the distance between your eye and that position of the rod with the help of a scale. Repeat this activity with different lengths and note down the distances. For healthy human eye, the least distance value is about 25 centimeters. The least distance of a healthy human eye is about 25 centimeters. Are you able to see if any person stands besides you without turning your head? No, we have to turn our head. We have to move our head up and down, right and left to see the objects, to see the things, to see the persons. Why? Because of human eye can cover a small angle of region only. So that angle of region is known as angle of vision. In the same way, again we have to do the activity like with the help of the rod of a particular length, and place closer to your eye and move away from your eye horizontally and fix it a position at which you can see the top end and bottom end clearly. Now draw the lines from bottom end to the eye and the top end to the eye. The angle between these two lines is known as angle of vision. The angle of vision for a healthy human eye is about 60 degrees. So children, for our human eye, the least distance is 25 centimeters and angle of vision is 60 degrees. You have to note down it. It is very important. So this is average value only. It may be varies a small value person to person. I am going to explain you how the human eye works, how the human eye able to see the things. So you already studied in your biology lesson, but once again take a look on the structure of human eye. So children, see this. This is a human eye structure, and you know that this is the human eye. The eyeball is almost in spherical shape. The front portion is little more curved and it is covered with the transparent protective membrane is known as cornea. And this is our eye lens, which is hard in the middle part, and when we move away from the middle to the edges, so it will become softened. And these are the iris, these are the ciliary muscles, and this is the retina on which the image is formed, and this retina is connected to the optic nerves which are sends the signals to the brain. So here is a small area, small portion of eyeball which is in colored part is known as pupil. Iris makes pupil as a variable aperture. This means iris makes pupil to contract whenever the bright light conditions. So when the more light is there, then the pupil get contract with the help of iris. So then it can avoid entering the excess light into the eyes. In the low light condition, iris makes pupil to expand to allow the more light into the eye. There is a distance between eye lens and the retina equal to the 2.5 centimeters. So you can observe here, children, eye lens is in the shape of convex lens. The distance between lens and the image which is falls on the retina is known as image distance, which is equal to the 2.5 centimeters. This is the structure of human eye, children. So whenever the light is enter into the eye lens, the light rays are converges the light beams on the retina and forms the image on the retina, and the optic nerves carries the signals to the brain and we can perceive the image. So observe this ray diagram. So the light rays coming from the longer distance falls on the eye lens and forms the image on the retina. We already explained now the distance between eye lens and retina is 2.5 centimeters, means image distance is 2.5 centimeters. So, but we know that as per our previous knowledge, whenever the object distance is changes, image distance is also changes. According to the lens formula, 1 by f equal to 1 by v minus 1 by u. But here we have to get constant image distance. When you get the image distance is equal to 2.5 centimeters only, image falls on the retina, we are able to see the object. But how it is possible for every different distant objects which are at different distances, how can we get the image distance is constant? This is only possible whenever the focal length of the lens is changes. But how the focal length is changes? Focal length is depend on what? The focal length of the lens is depend on the radii of curvature and as well as the material by which it made. We cannot change the material because of eye lens. These are the eye, we cannot change the material. So there is only possibility there is a change in the radius of curvature. So how it is possible? Let us see this. The light rays are coming from the longer distance, falls on the eye lens and forms the image on the retina. In this condition, the ciliary muscles which are attached to the eye lens are relaxed. Now the eye lens have the more radius of curvature, that's why the focal length is maximum. When the object is at least distance, observe the movement of the ciliary muscles. The radii of curvature of eye lens is decreases and the focal length is also decreases. Whenever the object is at longer distance, our eye lens has a maximum focal length, and whenever the object is closer, then the eye lens focal length is minimum. So like this, our eye lens adjusts itself with the help of ciliary muscles, the focal length is varies. This self-adjustment with the help of ciliary muscles is known as accommodation. The ciliary muscles adjust the focal length in such a way that image is formed on the retina. So what type of image is formed? By this our eye lens. So you already observed the eye lens has a shape of a convex lens. So that's why the image formed by this convex lens is, as we know that it is a real image and inverted image. So observe this ray diagram. Here the image is formed on the retina which is inverted and real image. But the question is, when the inverted image is formed on the retina, then how we are able to see the objects erectedly, and how the human eye can recognize colors and shape and size? For this question, so observe this diagram, children. The retina membrane consists 125 millions of cones and rods. So these are the cones, and cones identify the color, and the green colored oval shaped are known as rods, which are identify the intensity of light. So these cones and rods receive the signals, and these signals send to the brain with the help of optic nerves, and sends the signals to the brain to perceive the object in terms of size, shape and color. So just now we explained about the accommodation of the eye, that is eye lens is adjusting its focal length like maximum to minimum. So what is this maximum focal length of eye lens and minimum focal length of eye lens? Let us find out. The maximum focal length of eye lens. So whenever the object is at longer distance, focal length of the eye lens is maximum. So here observe this ray diagram. The light rays are coming from the longer distance, which are parallel to the principal axis, incident on the eye lens and forms the image on the retina. For this situation, the object distance is taken as infinite, and the image distance, which is equal to the 2.5 centimeter, which is constant, that is distance between eye lens and the retina. As we know that the lens formula 1 by f equal to 1 by v minus 1 by u. Substituting the values in this equation, that is 1 by f maximum equal to 1 by 2.5 plus 1 by infinity. We know that 1 by infinity is 0. Then 1 by f maximum equal to 1 by 2.5. F maximum equal to 2.5 centimeters. So this is the maximum focal length of our eye lens. Now let us calculate the minimum focal length. Whenever the object is at least distance, the focal length of the eye lens is minimum. So let us calculate. The object is at least distance. Here the light rays are coming from this point, incident on the eye lens and meet on the retina and forms the image on this. In this situation, the object distance is equal to 25 centimeters because of it is a standard value taken for healthy human eye, that is u equal to 25 centimeters and image distance is v equal to 2.5 centimeters. Substitute in the lens formula 1 by f minimum equal to 1 by 2.5 plus 1 by 25 and calculate the value as 1 by f minimum equal to 11 by 25, then f minimum equal to 25 by 11, then the answer is 2.27 centimeters. The minimum focal length of eye lens is 2.27 centimeters, means the range of these two values, that is from 2.5 centimeters to 2.27 centimeters. In between these two values, the eye lens focal length is varies with respect to the different distance objects. So how the object distance is changes, likewise the focal length of the eye lens is adjust itself. This is known as accommodation. What happens, children, if the eye lens is not able to adjust its focal length in between these two values? When you observe the objects which are at longer distance, the maximum focal length is greater than or less than 2.5 centimeters. What happens when you observing the objects which are at least distance are greater than 2.27 centimeters? What happened? So the objects are not visible clearly. The objects will be appears as blurred. This is known as defects of vision. So most common, there are 3 defects. Those are myopia, hypermetropia, presbyopia. Let us discuss about these defects. Firstly, I am taking myopia. Some people can see the objects which are near to them clearly, but not the objects which are at longer distance. So this type of defect is known as myopia. So also known as nearsightedness. For these people, maximum focal length of the eye lens is less than 2.5 centimeter. For better understanding, observe this ray diagram. With the help of ray diagram, we can understand the myopia. So whenever the object is at longer distance, the light rays are coming from this parallel to the principal axis, incident on the eye lens, and the focal length is less than 2.5 centimeter. The maximum focal length is less than 2.5 centimeters. That's why the image is formed in front of the retina, not on the retina. Due to this reason, we are not able to see the object clearly. It appears as blurred. and this is L, least point, least distance, and this M is known as a far point or extreme point. Means beyond this point, whatever the objects are there are not visible clearly, but when you place the object in between M and L, you can see the objects clearly. See another ray diagram here. Object is kept little close to the far point, but still the image is formed in front of the retina. So observe here children, whenever the object is placed at M point, that is far point, then the person able to see the object clearly. Here the eye lens forms the image on the retina. When you place the object in between far point and least distance also, you can see the object clearly. Eye lens can form image on the retina. Children, these ray diagrams are very important. So it's very important for our examination also. Everyone has to practice it. So this is about myopia. Then when you approach the doctors, they suggest the lenses to correct your defect. So how to correct this myopia defect? To correction of myopia defect, we use biconcave lens. For better understanding, observe this ray diagram, children. Correction of myopia. Here is biconcave lens placed in front of the eye. Whenever the light rays coming from the longer distance incident on the concave lens, and it forms the virtual image at far point. Whatever the image is formed by this concave lens act as an object for our eye lens. So now our eye lens receives the light signals which are coming from the far point. So that's why it can form the image on the retina. So we can see the object clearly. Observe children, once again, when the light rays coming from the longer distance incident on the concave lens forms the image on far point, we have to choose like that. Virtual image. This virtual image formed by this concave lens behave as an object for our eye lens, and it can form the image on the retina. So this is the way to correct the myopia. How to choose the concave lens? With what focal length of concave lens we have to use? So let us calculate the focal length of the concave lens. So when in this condition the object is at longer distance, that's why the object distance is taken as infinity. Here the negative symbol indicates so the object is in opposite to the incident light ray according to the sign convention, and the image distance is equal to the far point. So means image has to be false on the far point. That's why image distance is taken as the far point, which is symboled with capital D. This is also according to the sign convention, it is negative. So as we know that lens formula, substituting all these values in this equation, you will get 1 by f equal to 1 by minus d. Here 1 by infinity, 1 by u is nothing but 1 by infinity, which is equal to 0. That's why 1 by f equal to 1 by minus d and f equal to minus d. To understand this formula, let us do a small problem. A far point of person detected by a doctor as 150 centimeters. What will be the focal length of the biconcave lens? So here in this problem, the far point is given as 150 centimeters. So capital D value is taken as 150 centimeters, and we have the formula for this concave lens is f equal to minus capital D. So f equal to minus 150 centimeters. Here minus indicate it is a concave lens. So f equal to minus 150 centimeters. We have to choose the concave lens of focal length 150 centimeters. So like this we can calculate the focal length of the concave lens to correct the myopia. Let us discuss about the hypermetropia. Some people are not able to see the objects which are closed, which are nearer object, but they can see the objects clearly which are at longer distance. So this type of defect is known as hypermetropia and also known as farsightedness. The minimum focal length of the eye lens is greater than 2.27 centimeters. So this is hypermetropia situation. So when the object is at least distance, the image forms behind the retina. Here the minimum focal length is greater than 2.27 centimeters. So that's why the image is formed behind the retina. So when the object is L is least point, that is 25 centimeters, and here H is near point. The near point means the point of minimum distance at which the eye lens can form clear image on retina. If you place the object before this point, you are not able to see the object clearly. Let us see this diagram. So when the object is placed in between near point and least distance, the image is formed behind the retina. This is type of defect is known as hypermetropia. When the object is placed at near point, then we can able to see the object clearly because of the eye lenses forms the image on the retina. If you place the object beyond this point also, we can see the objects clearly. How can we correct this hypermetropia? What lenses we have to use to correct this hypermetropia? Yes, we use convex lens, biconvex lens to correct this hypermetropia. So observe this ray diagram. This is the correction of hypermetropia. When the object is placed at least distance, the image formed by convex lens, which is a virtual image on near point, which is act as an object for our eye lens, and it can form the image on the retina. So this is the condition. Convex lens forms the virtual image whenever the object is placed in between focus and center of the lens, optic center, the virtual image is formed. This condition is used in this case. The convex lens forms the virtual image at near point, and this virtual image act as a object for our eye lens, so it can forms the image on the retina. By using biconvex lens, we can correct the hypermetropia. But which focal length of convex lens we have to choose to correct our hypermetropia, because of different people have different near point values. So that's why we have to calculate the focal length of the convex lens which is used to correct hypermetropia. Let us derive that one. The focal length of biconvex lens. In this situation, the object is at least distance, so that's why object distance is taken as a minus 25 centimeters, and image distance minus d. D is nothing but near point of the person. So this is the lens formula, 1 by f equal to 1 by v minus 1 by u. So substituting all the values in this equation, so 1 by f equal to 1 by minus d minus 1 by minus 25. Now 1 by f equal to 1 by minus d, minus into minus it will become plus 1 by 25. Now we can write like this, 1 by f equal to 1 by 25 minus 1 by d. Then 1 by f equal to d minus 25 by 25d. Then f equal to 25d by d minus 25. So this is the formula for the calculating the focal length of the biconvex lens. Understanding this formula, let's do a small application problem. A near point of a person who has hypermetropia is 50 centimeters. Find focal length of required convex lens. Solution for this. Here the near point value is given as 50 centimeters, children. So we have the formula, that is f equal to 25d by d minus 25. Now f equal to 25 into 50 by 50 minus 25. So then focal length is equal to 1250 by 25. Then the focal length is equal to 50 centimeters. So like this we can calculate the focal length of the convex lens which is used to correct the hypermetropia. Let's discuss about the presbyopia. Presbyopia is a defect occurs due to the failure of accommodation of the eye lens. That means the eye lens is not able to adjust the focal length which are equal to 2.5 centimeters and as well as the 2.27 centimeters. So this effect is generally comes with respect to the aging. So for aging people, like when you observe your grandmother, grandfathers, they are not able to see the objects which are closer, and they are not see the objects which are at longer distance also. This type of defect is known as presbyopia. So the correction of presbyopia you will learn in the higher classes, children. When you get the vision defects, you go to the doctor, eye specialist. Then the eye specialist gave you a receipt with the numbers -2, right eye, +2 are like this. These values are nothing but power of lens. So what is this power of lens? The degree of convergence or divergence of light rays that can be achieved by a lens is expressed in terms of power, or we can define like this also. The reciprocal of focal length is called power of lens. Power of lens P equal to 1 by F. Whenever the F is taken in meters, P equal to 100 by F whenever the F is taken in centimeters. So the unit of power of lens is diopters. To understand this power of lens, let us do one small application problem. Observe here, the focal length of a lens suggested to a person with hypermetropia is 200 centimeters. Find the distance of near point and power of lens. So here hypermetropic person is given, that is focal length of the lens is 200 centimeters. So we have formula for the focal length of the lens of a hypermetric person, that is 1 by F equal to 1 by 25 minus 1 by D. So 1 by D equal to 1 by 25 minus 1 by F, interchanging the parameters, that is 1 by D equal to 1 by 25 minus 1 by F. Now 1 by D equal to 1 by 25 minus 1 by 200, that is focal length is given as 200. 1 by D equal to, taken LCM as 200, then you will get here 8 minus 1 by 200. Now D is equal to 200 by 7. Now the near point D is equal to 28.57 centimeters. So we use here the focal length of the convex lens for hypermetropia defect. Now calculate the power of lens. Power of lens P equal to 100 by F. Why I am choosing here 100? Because of here the F is taken in centimeters. F is given in centimeters. Here the focal length of the lens is given in centimeters. That's why I choose this formula P equal to 100 by F. P equal to 100 by 200 by substituting the value of focal length. Now the value is P is equal to 0.5. The unit of the power is diopter. Now P equal to 0.5 diopters. As it is a hypermetropia, so you get the value is as a plus 0.5 D. So plus indicates it is a hypermetropia. If you get the negative symbol, then it indicates myopia. These are the points we learned in this session. So once again, recap these all the points. Just take a look on whatever we learned in this session. The least distance of distinct vision is about 25 centimeter and angle of vision is 60 degrees. The ability of eye lens to change its focal length with respect to the object distance is called accommodation. The defect in which people cannot see objects beyond far point is called myopia, or also known as nearsightedness. To correct myopia, we use biconcave lens. The defects in which people cannot see objects situated before near point is called hypermetropia. Hypermetropia corrected by using biconvex lens. Presbyopia is a vision defect indicating defect in accommodation of the eye, usually arises with aging. The reciprocal of focal length is called power of lens. The unit of power of lens is diopters. Children, these are the points which we learned in this session. Children, practice more ray diagrams, very important, that is myopia and correction of myopia, hypermetropia and correction of hypermetropia. These ray diagrams are very important and practice more and more to get perfection. So to improve your learning, just try to answer these questions. Observe the screen, children. Explain accommodation. What is myopia? Explain with the help of ray diagrams. How do you correct the myopia? Explain hypermetropia with the help of ray diagrams. How do you correct the hypermetropia? What is power of lens? What are its units? For more questions, visit the SIET website, 𝗧𝗦𝗔𝗧.telangana.gov.in. So download the worksheet and try to answer the question. If you have any doubt, communicate with your subject teacher and try to practice more and more. Thank you children. Have a nice day.